Hey guys, how's it going? I hope everyone's doing all right, and I'm looking forward to today's stream, which we're going to be doing physics, hopefully. It's a little bit misleading because we will be doing physics, but first I want to take a look at some profiling because I made the cardinal sin of programmers, which was I basically did not check or did not profile my code before I tried to optimize. Now, how's it going, Langors? I hope you're doing all right. It's good to see you there. So, yeah, in the last couple of streams for the Coding Minecraft stream, basically we got to the point where we got some chunks loading, and I prematurely said, this is slow. I know what I can do to speed this up. Let's parallelize this in multiple threads, which isn't a bad thing, but it's not what you should do if you have slow code. Like, that's not the first step I should have taken. The first step I should have taken was let's profile the code to see what the slow part is and try to optimize that as much as possible, then go to multi-threading. So basically, I just want to undo the multi-threading to check and see what the slow parts of the code are, because I have a feeling it might actually be memory allocations, and it's not actually what I thought it was, which was just, oh, it just takes a long time. So I kind of want to see that, because if it's memory allocations, we can speed that up pretty significantly by just setting up a memory manager. But yeah, once we get that done, though, I do want to start on physics. So yeah. And how's it going, Tree? I hope you're doing all right. By the way, I added both of you guys as moderators, so you should be able to moderate the chat. And I added one more person too. I can't remember off the top of my head, but I'm going to reach out to a couple other people in the Discord too. So you guys should have that power now, and I trust that you'll make the right decisions. So that if we have spammers and stuff, that you guys will just take care of that. So yeah. But anyways, like I said, we're going to take a look at profiling this code to see what the actual optimization paths we should be taking are, because I have a feeling it's going to surprise me what's actually taking up the most time. So basically what I'm going to do is basically just take this out of a thread, the synchronized chunks, and I'm just going to do all of this synchronously instead of the way I was doing it before. So we can do that by getting this function, which I think was just like thread workers or something like that, or like, oh yeah, chunk worker. So basically I can just call this function at the end of each thread, and what we can do is I'll remove this while loop and this conditional variable, and I'm going to take this out here too. And I'm basically just going to say if chunk needs work, which is the same thing we were doing before, then I will do all of this stuff. And then do that. I'm going to leave all the lock guards in there too and stuff, because I don't think that should be a problem at all. So yeah. And no problem. I was glad to add you guys as moderators, so that's good. And Flare YouTube, how are you doing? Good to see you. So what we're doing right now is I'm just undoing the parallelization that I did. So getting threads out of here so that we can profile the code to see what's actually taking up the most time, because that's what I should have done first. But yeah, we're just going to leave the lock guards here because that shouldn't affect anything. I am going to turn off that notify all because we're not going to be using the conditional variable. Actually, let me just comment out the conditional variable so that I don't get confused. And then I also have a little thing here that I was looking up earlier. Do I still have it up somewhere? I think I do. Maybe I don't. Maybe I left it somewhere. Uh-oh. Well, I did have something that was basically like how to do multi-threading. And yeah, I don't think I'm going to find it right now. But I'll try and look for that a little bit later, because it was basically a good little tutorial on Stack Overflow that went over that. And Flare YouTube, can you have moderator? Are you part of the Discord, Flare YouTube? Because there's a couple people who have different usernames and stuff too. But basically, I'm just adding people who are part of the Discord and everything and who reacted, just because I've kind of seen how they've behaved on the Discord, and it's given me sort of a track record of they are. Okay, you are. Flare YouTube, what's your username on the Discord? Because I might have just seen your, but like not connected the dots. Flare Dev, why don't you react to the notification on the Discord in the announcements page? And then after this stream, I can add you as a moderator too. Because, yeah, I think we should be good. So, yeah. Okay. Anyways, though, yeah. So we're going to comment out this conditional variable. And then That should hopefully bring up a few different errors. Yeah, so then I can just comment this out. And then at the end of the function, I'm just going to say chunk worker. Yeah. If I just call that, that should do what we need it to do. And then I'm going to get rid of the thread initialization, which was right here. And we should be good. And then instead of doing that too, I'll just say chunk worker, which should run our function. Yep. And how's it going, Etsy Woods? Hope you're doing all right. Okay, cool. So if we run this, it's going to be slow again, hopefully, once I get it to work, which I just need to comment that out, and we should be good. And then we also don't want to join the thread anymore. So we should be able to go fine, and then it should be pretty slow. That was actually pretty fast. Like, it was slow for sure, but it wasn't as slow as I thought. If we hit, okay, yeah, and then you can see every time I hit something, it's just going to slow everything down because we are no longer multi-threaded. That's good. What I'm going to do next is I'm just going to launch the profiler, which we can do in Visual Studio by just basically start debugging. I'm going to add a key binding just so that we wait until I hit a key before we start doing anything. So let's go into application.cpp real quickly. That way I can just get like the debugger turned on and everything and get the profiling up and running, and then we can initialize it to track exactly the stats that I want. So if I go down here, this is where we initialize the world. So I'm just going to say while not key listener. I think I have a key listener. Hopefully I do. We will check that. So we'll say hash include render / input. Oh, I do. Okay. And I think I called it input. So if not input, key pressed. So is key pressed. And then we'll pass it glfw key, and I'll just do space key. So once I press the space key, we'll just continue. So yeah, so we'll stop here. That way the world doesn't initialize. And then once we do this, we will continue. And can I do a sleep? Because that might be good too, just so I don't, it doesn't matter too much. Okay, anyway, so if we do this, we should be good. And 00.00 here, so you won't stay too long. Oh, okay, it's like midnight for you. That's no problem. It's good to see you, and I'm glad you were able to make it for a little bit anyways. So I probably won't be streaming on Saturday too. I should tell you guys that now. I'm not going to have any time on Saturday morning, but I might try to stream Friday at 5 p.m. CST as well, just to make up for that. So yeah. Okay, so let's go to diagnostic tools. And then we can go down here and we can just hit record CPU profile. So this will begin recording the CPU, and I lost the key bindings. Okay, so it looks like we can't do this or we can't do that without a sleep. So let me just go and include system real quick or something like that. Let me see, because there should be a pretty easy way. C++, if I can get in here, C++ system sleep, because otherwise the window freezes because we're doing that. Okay, so if we just include thread chrono and then we just do this. Okay, this is what I wanted. Yeah. So if we just include windows.h real quick, and then I just say sleep for 100 milliseconds. Okay, there we go. That should just be so that the window doesn't freeze up and everything. Okay, so we should be able to go to here, hit record CPU profile. Oh, it was recording already, but that's fine. Okay, maybe I'm just going to leave that on instead, and we'll just get rid of this. So it should start with recording on, because I guess I can't get that to work without the window freezing. So if we go back here now, it should be recording immediately. Okay, it is recording, and we're loading everything, and so I just want to stop recording right after that. Okay, cool. So then I think if I stop it, we should save all that, but I'm not completely sure. Okay, so if we just select this range and I hit stop, I think we should save that. Hopefully. I haven't done debugging in this or profiling in a while, so I always forget how it all works, and it's kind of annoying right here. Okay, so if we look at the performance profiler, we do this, maybe this time. Okay, I think this is what I was looking for. I was just looking at the wrong thing. Okay, so if we do that, and then we hit stop collection. Okay, that's how we do it. Cool. So now we're going to get some good profile stuff on our code. Essie Woods, you said, I asked last time if you were going to use math animation application in YouTube vids, but had not watched the font video you made at that point. It was a great video, covered a lot of information in a short time there. Thanks. Yeah. It definitely took a while for me to edit all that together because the math animation library still wasn't very easy to use. I want to add like a graphical user interface to it and everything to make it a lot easier to use so that I can hopefully continue to use it in future videos and stuff. So yeah. But thanks. I'm glad you liked it and stuff too. Okay, so what we're going to do now is we're going to restrict our profile information to this thing here so that we can just see what's taking up the most time when we load the chunks. And so these are all the hot paths, and they do the fire to show that it's a hot path. And as you can imagine, it's going to be inside of our function chunk worker, which is allocating all the data and everything. So this all makes sense. We have 78% of the CPU time is taken up here. So we'll go drill down into that a little bit. And FlareTube, you're creating a programming language with your friends. We already added variables, print line, and for. Nice. That's pretty cool. Programming languages are really fun to experiment with. Yeah. Okay, so if we drill down into this a little bit, it looks like the two functions that are taking the most time inside of our... Okay, so it looks like the generate render data is what's taking the most time inside of here. So, yeah, this is really big for some reason. Yeah, so it's basically just showing us here. I'm going to... Yeah, I don't know why this is so big, but it's showing us that this logger is taking up 0.02% of CPU time. The allocate memory takes up 0.25% of the CPU time. And then once we get into here, it looks like this get block function is taking up a pretty big amount of time. And then these are the really bad ones. So this get texture format is just not good, which is interesting because I wouldn't have expected those to be the worst performing things. And then all this other stuff is like less than 1% of the time. And the reason I'm doing this too is because, like I said, I made the cardinal sin of trying to optimize before I actually profiled my code. And I had a feeling I would be surprised by the results if I actually profiled the code, and I am, because I was not expecting these results. But it looks like these three functions, so this get texture format is taking up quite a bit of time for some reason. So we'll drill down into that a little bit more. And you didn't even know Visual Studio had such debugging tools. I know, right? It does have a lot more. This is why I like using it for coding with C++, because you can do this type of stuff. And they have memory profiling too, but it's not great for C++ because it just kind of tracks the heap, but it doesn't do a good job, and it doesn't do like code tracking. C# is better though. So yeah. And Langors, which tools are you using? You've used Antler before. Oh, okay, to FlareTube. So yeah, let's go into this get texture format to see what's taking up the time here. And I guess it's just the std map, which is weird. I'm guessing it's because we're using a string, but that's still weird that it would take up that much time. So yeah, if we go into here, we can sort of drill into it a little bit further. So yeah, if we go into block map, get texture format. So we're using an unordered map, and it's just taking up a ton of time. And I'm guessing it's just because we're doing our indexing by strings. So there's probably a way we can avoid this. But I have no idea how. Let's Google this real quick, because std unordered map with string as key takes a long time. So I'm not sure what the best way to fix this would be. Okay, two unrelated sections. Std unordered map reserve. Okay. This shouldn't have any, so I don't care about like storing the stuff, but it's just lookups is slow. Yeah. And FlareTube, your friend is programming, don't know what he's using, but he's using language to make our language, Python-based language. Okay, cool. Yeah. Langors, you said that you've used Antler before and it was fun. I've used Flex and Bison. Yeah, I think it was Lex and Bison or Yak. I don't know. It was something. There's like a whole tool suite, but it's like Antler. And I used that before. And then you can also build it from the ground up yourself, which is pretty cool if you're working on a programming language. So I do recommend trying to like build it from the ground up too if you guys ever have a chance. But let's see what this guy says. He says approximately 1 million lookups in unordered map with string key works much slower than .NET code. Yeah, so Visual Studio 2010 use a performant hash function for stood string rather than an accurate one. Basically, if the key string is larger than 10 characters, the hash function stops using every character for the hash and has a stride greater than 1. So for size greater than equal to 10, use every second character at the first. Thanks to this, collisions happen more frequently, which slows the code down, of course. Try a custom hash function for the C++ version. Wow, that's interesting. Yeah, I mean, I would expect C++ to use the best method. I'm curious too, real quickly. Let's just do one more thing, and let's profile this in release mode, because I am curious if this speeds up by some magic that they do whenever they get release mode. So let's cancel out of this. I'm not going to save that. And then we'll do performance profiler, CPU usage, and I'm going to switch to release mode just to see if this does help us out at all. Because that's interesting. I would expect a C++ standard library, unordered map, to perform the best it can, no matter what, but I don't know. And then after this, we will try what that guy suggested if this does not speed it up. And we'll go ahead and grab, we'll create our own hash function. So I'll be interested to see if that speeds it up and everything. And SE Woods, Gabe, would it be okay to add multi-threading at a later stage of developing a game? Like when you get to optimization stuff, or will that be more difficult? You're planning to implement it for loading chunks like you, only in 2D. Whoa, first of all, that went way faster, which was pretty insane. So launch your stuff in release mode and just see the difference if you guys ever are curious about that. But anyways, in terms of parallelization, it's usually a pretty good idea to try and set up your code to handle that pretty early on. But as long as you keep big systems separate, you can usually get away with it pretty easily. So like most game engines, when they parallelize, they're not like doing, you know, tiny little micro optimizations. Usually they're parallelizing like big systems. So they run the physics update and the rendering update on separate threads, and the game logic updates all on separate threads. So as long as you keep those separate and like contextualized, I have a feeling it should be easier to make it parallel once you get to that point. So yeah, I think you're good going the way you're going, and then you can sort of see how the performance is running. And if you need to speed it up, you can look into techniques like this. So yeah. And let's go and see what the slowest thing is now, because I am really interested. I'm amazed at how much faster that was, first of all, just from changing that to release mode. So it looks like get texture format is still the slowest. And yeah, so it looks like this is still taking up quite a bit, but it's not as slow. Yeah, this is now 0.66%. And then this load block function is actually taking a longer time now. And it looks like it's just our logging call, actually, which is taking up the most time in this, which is also interesting. We can get out around that really easily, though, because I can compile the logs out of it. But this is an assertion, so I kind of want to keep that in there. I don't know. But it's saying that this function is also pretty slow. They're about equal if we take a look at this. And that's probably because we're using the at parameter here. But we are indexing directly into a vector, I believe. So this is a vector of block formats. Yeah, we're indexing directly into a vector. So that's kind of weird that this is taking up so much time too. I'm guessing it's just because of this though. But yeah, it looks like that speed up though, just by changing the release mode, got rid of this problem. So what I'm guessing is when you compile in release mode, they just like write all the strings into the executable directly. So that's why this was, or they just like hash the strings in the executable, which speeds it up tremendously. So yeah, that's really cool. And I'm not too concerned with the speed now, because just again, in case you guys didn't see that, this is running in release mode now, and just look at how much faster this is, okay? So if I move forwards, there was a little bit of a hitch there, right? Like we just kind of hit a little bit of a stutter there, but it's not that bad. compared to if we go back to debug mode, like I can't believe how slow this is. So like this is already taking way longer than it did. And then if we hit this, yeah, we stopped for like a full half a second to 3/4 of a second there. So yeah, but that was good. It didn't really show us much of what was happening. I had a feeling that allocating memory might be taking a while, but it looks like allocating memory isn't taking that much time. So I was going to make some optimizations there, but it looks like most of the code is pretty good. So I think parallelizing it is the only way to speed it up in this case. So we made the right call there, but it's always good to profile the code and make sure you made the right call before you actually do this stuff. And SE Woods, you're going to ask about the physics engine that was implemented in the Jade engine, if that should go on a different thread, ideally. Yes, I would say to put that on a different thread. I'm still not really happy with the way, like the custom physics engine that I wrote never really got finished in Jade, but Box2D, I'm pretty sure is thread safe, and you could probably parallelize that. So is Box2D thread safe? Okay, it says it's not thread safe. Okay, so yeah, that might be a problem, but if it has copies of all the data, I don't know. I would probably look into seeing if other people have done this if you're using Box2D, but if you're using some other things like this looks like it might be with multi-threading and stuff. But yeah, if you're doing your own custom implementation though, I would definitely say put that on a separate thread if you want. But it's pretty complex, so I would also say wait until you have a reason to add that extra complexity. But yeah, and SE Woods, you can donate to Gabe. You don't even have $1. Okay, debug adds so much overhead. It really does, yes. And does Unreal Engine have their own physics engine? No, I think Unreal uses Havoc. Let's just check real quick. I'm pretty sure they use Havoc though, or no, okay, they use physics by default. But I thought they did. Maybe they don't. Maybe I'm thinking of somebody else. Oh, and then they have Chaos Physics, which is currently in beta release. Okay, so maybe they are adding something which is their own thing, unless this is somebody else's tool. Yeah, so that's interesting. So they might be using their own tool, but they're using physics for now. Okay, cool. So we can probably add the parallelization back in, but there was one other thing I wanted to do too, which is, this is a good idea now. So I was looking up earlier and how to reuse threads in C++, because I want to sort of change the way that I'm using my threads for the chunks, because I really don't like the way it's working right now. And it wasn't this one, I don't think. Maybe it was that one that I was looking at. Yeah, I think it was probably this Stack Overflow question I was looking at. So basically, what I wanted to do was right now what we're doing is inside of the world, we've got one array. And this is an array of chunks. And it's just a raw pointer, right? We just have like data, which is chunks, and we iterate over that at runtime multiple times. First of all, I don't know why I made this a dynamic array. I could have very easily made this not dynamic. Or maybe I did it just so that I could, yeah, because I have this chunk capacity. And then it looks like I'm just allocating this chunk capacity. Yeah, so I'm not quite sure why I did this when I could have just done this. So first of all, we'll change it to this. But I'm still not happy with this because, and I declared that wrong. What this means is we have to iterate over this with a separate thread, and we're both sort of touching the data at the same time, and that's not good. So if we look at a chunk, like how much stuff does this actually have? It doesn't actually have that much stuff. All of this doesn't exist on the structure itself. All we have is one pointer. We have this chunk render data, which is just, if we look in this, it's just a pointer, and this render state, which is 2 integers. So far we're up to like the size of 6 integers is basically what this is. And then if we continue looking through that, we also have 2 more integers, so that's 8 integers, and then this is like 9 integers. Okay, so this is 9 integers. It's a really small amount of data, and there's no reason why I should have to operate on the same data the way we're doing it in here. Like, there's no reason that I should have the thread operating on the same data. Instead, the better idea would be to, oh, cool. Thank you, SC1s, for donating $10. That's awesome. But basically, we don't really have to do operate on this stuff at the same time. Instead, we can just say, hey, like, here's some data. I want you to generate a chunk. Hand me back, like, copy the data back to me when you're finished. That way, we never have 2 things operating on the same array at the same time. So that's what I want to do. If that made sense, I hope it did. That's sort of what the plan is now. Okay. So in order to do that, we can use this idea, which is basically, he's saying, like, create a thread pool. I'm not going to really do that, but basically what we're going to do is we place jobs on a queue. Actually, this might be pretty nice. Let's see if there is a thread pool, because this might be easier than trying to just implement it myself and everything. Let's see if there's, okay, C++ 17 thread pool for high performance scientific computing. We might just do this instead. And Flare YouTube, my friend just added the void and if functions to our language. Energy script, cool. That sounds good. Okay, types are pretty hard when you start adding those to languages and stuff. Okay, so they're saying this is a modern C++ 70 compatible thread pool implementation built from scratch with high performance scientific computing in mind. It's a single lightweight self-contained class and does not have any other dependencies other than the C++ 17 standard library. I am using C++ 17, so that's good. And okay. So if it's fast, I think that's all that matters for us, right? We just want something fast. Let's see how you use it. Do they have any examples? Okay, it looks like they've got some. Okay, so you basically initialize a thread pool and you tell it how many threads you want it to have. And then you use futures and you just say submit a task. Okay, that's fine with me too. And then you just say myfuture.get. Okay, can you query to see if the task is done yet? Because that's really what I'd want to do. It's just to check and see if it's done or not. Okay, so you can do pool.wait for tasks. This looks pretty cool. Yeah, I think we'll experiment with this and see if this can help us use a thread pool. So basically, if we can use a thread pool, then we can parallelize this way easier than what I've been doing and everything. And Langors, you said std async does something kind of similar to thread pool. Yeah, but std async doesn't reuse the threads, and that's the one thing I'm worried about. Not that I know of. We'll check real quick. But I don't think it does. Okay, thread local and helper libraries may have some state. These are reasonably expensive. Each thread has a different state. Okay. Doesn't look like they're answering this. So we have a lot of tasks. Isn't it too much threads for doing nothing? Why waiting threads can't be reused? Okay, so this says the sharing does happen, but at the core level, not thread level. Since your threads are doing virtually no computation, it's likely all 160 threads can share a single CPU core. Yeah, I'm pretty sure that these aren't actually sharing threads. So it's like creating new threads and everything. And that can be costly. So if you know more about that and have some documentation that says otherwise, that would be great to know too. And AC Woods, thanks for the answer regarding the threading of the physics engine. Never really used several threads before, so think you'll do it later stage. Might very well finish the physics engine. That was awesome. Cool. Yeah. And no problem. Multi-threading is definitely a whole new ball game. I feel like it's pretty difficult to do it well. So coming from somebody who's just sort of figuring this stuff out now too. Yeah, so it looks like std launch async indicates the function call must be run on its own new thread. Std launch deferred indicates that the function call is to be deferred until wait or get is called on the future. And other stuff. And I think that CPP reference answers your question. Oh, okay, cool. So if we do std async this function template asynchronously, potentially a separate thread, which might be part of a thread pool. Okay, so this function template async runs the function f asynchronously, potentially in a separate thread, which might be a part of a thread pool, and returns std future, which will eventually. Okay, cool. So if that's true, then we may as well just experiment with std async. So we'll see how this works. Is this part of C++ 17 or 20? I think this is 17. Let's see. It looks like it might be part of 11. Okay. And yeah, so let's try that out. We'll see if we can use hash include future. And I'm actually going to put these into core.h. The best thing to do is probably for me to just start coding and see what happens. And we'll go from there. Okay, so basically what I want to do is, if we take a look at this, we can launch threads. Yep, so we get a handle, and then this will basically wait for the thread. And we can say launch async parallel sum, so it does all that stuff. Okay, cool. So I want to have a function that basically creates the chunk. So we could say something like, where I have my static declarations up here, we could say like static chunk, create chunk, or generate chunk, or whatever we want to call it. And then this will take in just like int x and int z, which I know we already sort of have, but this will just create a whole new chunk object for us, which should make it a little bit easier. We also no longer have to do this, so that's good. I will still zero out the memory. I don't think I have to, because I think this should zero out the memory initially, but we'll do that just in case. And what C++ version am I using? Or yeah, Fire YouTube. I'm using the C++ 17. So yeah. Okay. Anyways, let's go down here. So we zero out that memory, and then we no longer have to do this. So that's kind of nice. And then we'll say check chunk radius. And we basically want to have like a way to return those chunks, which is just going to be a bunch of futures, I guess, right? So we'll have like a static std future of chunk. And we're going to have an array of futures. And this will be waiting chunks. I guess we could call this like a std queue, because that makes a little bit more sense. I'm not sure how the queue works, so I might have to look into that. But we'll say queued chunks. And it doesn't like this. Let me see if I have that included. Queue. Okay, there we go. And if we go back in, we are good. Okay, cool. So we'll have a queue of futures, which are the chunks that have been queued up. And as these get filled, we'll sort of use them. So inside of here, I'll just initialize that. So we'll say queued chunks equals that, which should just initialize it to like an empty queue, hopefully. And then when we check the chunk radius, instead of doing all this stuff, we'll make this a little bit easier. We no longer have to do this whole loaded chunk positions.find thing and look for chunks within this. So that should be a little bit easier. And I see Woods, did you know that physics engine have world limit of 2 kilometers? In box 2D, you can shift the origin when you exceed the distance, but the method is missing from JBox 2D. Huh. That makes sense to me, because floating point numbers do weird stuff once you get to a certain like distance from 0. So I have heard that it said like certain games and stuff, yeah, will do exactly what you said, which is basically like you shift objects so that you don't run into that problem. I think what I was doing in the case of my engine was basically you did all the physics operations local to the objects. So like you tried not to use world coordinates as much as possible. Try to use local coordinates. And if you use local coordinates pretty much the whole time, you shouldn't really have to worry about that. but there are cases when you have to shift back to world coordinates, and then you could run into problems and stuff. But yeah. And space games are essentially doing that because of the massive worlds. Yeah, I would hope so. So, okay, so we've got this find unloaded chunk, and instead of doing this, what we can do is, yeah, we don't have to do any of this stuff. We can basically just say, okay, we're gonna have to change up like the whole way that this works. So first of all, I'm gonna remove all of this stuff. Maybe we should keep like loaded, but that's not gonna be very useful. So we can remove all of that stuff because we just don't care about it. And if we go into chunk.cpp, we're going to have to like change up a few functions. So I still want to have generate render data, upload to GPU, free CPU, free GPU. So those should still be separate. And then this generate function and, okay, yeah. So we have generate render data, upload to GPU. Okay, so this is like the CPU stuff. This is GPU stuff. Actually, no, I think this is GPU too. Well, yeah, okay, this is, okay. So we're still going to keep that separate, but we're going to change up the way these load functions work. So if we scroll down, basically these load functions don't really do anything, and that's fine. We can just remove them. So we'll do that. We do need to free the CPU still, though. And instead of doing this, what we'll say is if render data dot vertices. So if this, basically we'll just check if it's not a null pointer to protect against that. Then we'll free that memory and then we'll set it to null pointer. And then we'll just say if chunk data, then we'll do the same thing. Okay, cool. So now we don't have to worry about like loaded stuff. Okay, and then free GPU. For this one, what we can do is we can just check and see if these are -1, which is what we'll assign them to if it's not loaded. So we'll just say if render data dot render state dot VBO does not equal -1, then we'll free the VBO. So we'll do that. And then we'll say if render data dot render state dot VAO does not equal -1, then we'll free the vertex array and then set it to -1. Okay, so that should take care of those, which is good. And now we don't have to worry about those loaded strings or whatever at all, loaded booleans. So we can get rid of them here as well. Okay, so now everything is separated and we don't have to worry about weird complex things because everything will just sort of be handled by the futures, which will hopefully make this easier. So yeah, and I'm just gonna catch up on the chat real quick. Okay, you guys are just talking about physics stuff and everything. Yeah. So physics is super complicated. And I'm sorry if I misled you guys by saying we were going to be doing physics today. I still do want to get to that in just a minute. But I wanted to get this done too, because I'd been thinking about all of this stuff for quite a while. Okay, so anyways, we don't really need this find unloaded chunk function anymore. So I am just going to get rid of this. But we do still need a way... Because I guess we do still need a way to tell if it's loaded or not, just so that we can keep this array and know which ones are loaded. So we will keep that, just one boolean. So we'll say bool loaded equal, well, I can't initialize that, but we will, that will be 0 initially, so we should be good. And then inside of here, when we upload to GPU, so let me go here. When we upload to GPU, we'll say that loaded equals true. And then we free from GPU. Okay, and we can get rid of this stuff too. And then when we free the GPU, we can say that loaded equals false. So that'll sort of be the final milestone we have to get to. We can separate these out if we encounter errors, like loaded on CPU, loaded on GPU, just if we need to in the future. For now, that should be fine though. So yeah, that way we can tell if things are loaded or not, which means we can appropriately fix everything up. Okay, so which one was I checking? Okay, I was checking this. So yeah, we still don't really need to do this whole find unloaded chunk thing. So basically, if we find that we need to load a new chunk, what we'll do is we'll say queue, which I think I called it queued chunks, yeah, dot push, And then we're going to push a new future. So if we take a look at this stuff, we can create a future by just doing stood async and this stuff. So let's copy that. So we'll say stood async, stood launch async, and then we need a function, which is what I believe this is, right? What's this stood async? I think we need to add that to core.h real quick. So let's add async future. No, we got future async. Here, let's see. Because I think I'm missing an include. This is, nope, defined in future. They've got vector, algorithm, numeric, future, string, mutex. We might need algorithm too. Let me just do that real quickly. If I don't already have algorithm, yeah, I'm going to need that anyway, so it's good to have that. Okay, no, still doesn't like async. Oh, it's just because I have an error in there. Okay. And just making sure Sebastian League is awesome. I'm glad you guys like him because I really like him too. And also Tree and Langurs, your guys' name tags look almost the same to me just because the colors are very similar too. But yeah. Okay, so basically I just want to push an async or a future. Let's just do this real quickly. So this says if I type in stood async, let's see what we get. So it says it takes in, so fn arg, which is stood launch async according to that. And then it takes in arg types, and those are the arguments. And so it looks like it's calling a function there. Let me look at the documentation for real, because that'll probably help us out a little bit. So he says to do parallel sum, which is this function. Random it middle end. Okay, so he basically just calls himself. And if we look down here, this says stood async ref x foo. Okay, so that's kind of weird. So it calls x foo 42 hello with default policy, may print hello 42 concurrently or defer execution. Okay, so it looks like you just put the function you want to call here, and then you just pass in the arguments here. So the function I want to call is going to be basically something like generate chunk, or I think that's what we called it, generate chunk up here, which if we take a look, create chunk. Okay, so it's going to take create chunk and then it takes X and Z. So if we do create chunk and then we say position.x and position.y, that should give us an X and Z. Okay, cool, that works. So then this gives us a stood future of Minecraft chunk, which is what we want. And then we can just say queued chunks dot push that async, which is just a future, and we're good. Okay, cool. So that worked out. And then we should be able to insert the position, which is what we want to happen. And then we can remove all that stuff. So that's good. Cool. So that should push chunks that are queued for creation. And then what we can do is at the end of this, when we synchronize the chunks, I guess we can basically do it inside of there. So first of all, we need to fix this up a little bit too. So let's have a couple of queues. So this is the queue chunks for creation. And then we'll have a static stood queue, stood future of chunks. I guess we don't need to have this as a future. We could. Well, yeah, we'll have to have this as a future too. So we'll have chunks, queued chunks for deletion. Okay, and so that's how we'll sort of separate it, and we'll delete things and then we'll free them. So we'll change that real quickly. Okay, and so when we need to delete a chunk, we can just remove this. We need to erase the chunk coordinates, and then we need to say stood, well, I guess queued chunks for deletion dot push stood async, and then we'll say delete chunk, and then we'll pass it the chunk, which will be a chunk copy. We'll copy the chunk to the thread so we don't have any problems with like synchronization type stuff. And then we can get rid of that. So this will be we'll need a way to make sure that it's not unloading itself already too. So let's see. this basically just says if the chunk's out of range. So we can just say if the chunk's out of range and it's not inside of this, or yeah, it's inside of this chunk's position. So we can basically say Boolean has been queued equals, and then we can just say loaded chunk positions dot find local chunk pose, or chunk.chuck coordinates, I guess, which would be this. So we can do that. Does not equal. Cool. Essie Woods, thank you for donating $10 again, too. Thank you so much. Yeah. And Langors, you said, be careful. If you don't specify policy, the policy will be by default launch async or launch deferred. Okay. Thank you. I will check that out in a minute, too. So I guess you're saying that I need to do like a stood async and then stood policy. Okay, yeah, so they have like stood launch deferred and stood launch async. Okay, cool. So I will add those in real quickly too. And it's not going to show me any error messages too till I fix that, but we'll get that fixed in a minute. Okay, yeah. And so we're going to check and see if the chunk is working or not that. Okay, so we're going to check if it's been queued. So we'll say if this does not equal loaded chunk positions dot end. Okay. So this does not equal loaded chunk positions dot end means it has been queued? No. If this does equal it, then it means it's been queued. Okay, so we'll say if it has not been queued, and we have this whole thing. So that will basically just check for us if we need to delete it. And we might be able to, I think this should be pretty fast because this is a set, I believe. Yeah, this is an unordered set. So we should be pretty fast there. We shouldn't have to worry about anything. Whoops. I must have clicked on a link there. Okay, and then we can say stood launch. I think this was launch async. Nope, stood async launch. Let's see what they said. Okay, stood launch deferred. Okay, cool. So we need to do stood launch async. I'll have it as stood launch async for now, and then I will fix that up as needed. So in delete function is not defined, we'll create a for declaration real quickly, and then we'll go ahead and implement that. So we'll have static void delete chunk. And that was taking a copy on purpose because we want to copy the data so we don't run into like synchronization issues. And what's this say? Queued chunks is undefined. Oh, we should do that. And that. Okay, cool. So if it hasn't been queued for deletion, then we're just going to push the queue for deletion. And this says, oh, I just need to change what this queue is too, because this does not need to return anything. So this is just going to be a stood future void, which I hope is okay. Yeah, cool. So that looks like it's good. Okay, cool. So and then we also need to check in this. So this says for each chunk, if the chunk's loaded, and that's all we need to check now. So if the chunk is loaded, then we'll render it. Maybe we should change this a little bit too. So we'll say else here. Nah, I'll leave that there. So I was going to do that just so that we don't render things that are like queued for deletion. We'll fix that up in a little bit too. But yeah. And Langors, you said, I think async is what you want. Deferred will run synchronously once you query the future. So async is what you want. Okay, yeah. Yeah, that's definitely what I want then, because I do want it to run asynchronously. So yeah. And Icy Woods, you asked me some physics-related questions, but never saw you set stream topic to physics. You asked some physics-related questions, but never saw you set stream topic to physics. Can you clarify that, Essie Woods? So I did set the stream topic to physics because I do want to go into that right after I get this done real quickly. So this is, I'm just cleaning up the multi-threading a little bit because I don't like the way it's going to be going. But the future streams are definitely going to be all related to physics as well, because that's what I plan on starting to implement after this. And it's going to be very basic physics, so it's not going to be like anything too advanced. Like we're not going to be doing rotations or anything. It's probably just going to be like basic box bounds checking and that type of stuff. So yeah, let me clean this stuff up really quickly too. So this cleanup function is basically just going to say for int I equals 0. And this cleanup function is no longer being called either. That's fine. So we're basically going to replace this with this queued chunks for deletion function, which we'll figure out. So we'll wait on that. So for now, I'm just going to comment this out. I think we fixed check chunk radius. So this basically just adds it to the chunk queue. So that's all good. And then I can get rid of this too, because we're no longer dealing with that stuff. Okay, and then synchronize chunks. This is where things are going to be a little bit different. So instead of doing this, what we're going to say is for autoref chunk and queued chunks for creation, or I'll do deletion first. So we're just going to check all of these. What's this say? So the range base for it requires a suitably begin function. Okay, this should be a queue. Can I do queued chunks for deletion? Dot. We got pop front, which is what I think I want. So this should just like show us what's at the front. Let me just double check that so that we don't actually pop it off. So queue front. So this returns an element to the next element in the sequence. The next element is the oldest element in the sequence. And the same element that is popped out of the queue when queue pop is called. Okay, cool. Yeah, I think this is what I want. So front. Yeah, I think this is basically just going to show us what the front is without popping it. Okay. So we should be able to use that to basically check what the front is. And then I want to check and see if this is done. So let's see if there's a way to check and see if the future is done. Okay, yeah, so is ready. So we can just do that. So we can say if that is ready, then we'll say chunk, queued chunk equals queued chunks for deletion dot pop. So basically check that first thing off. And this is going to be a future. So we'll say dot pop dot. Looks like that's not going to work. So I'll just change this to a stood future of a chunk. And this will just be the queued chunk. And this says no suitable constructor to. Oh, okay, because this is going to be void. Okay, so maybe we should return a chunk here actually. So I'm going to change this up just a little bit right here. This is going to return a chunk on second hand. That way we can actually find it and like remove it from our main data. So then right here, this should be fine now, I think. I just have to change this. Yeah. Okay. So we'll change this to a chunk. Okay. Now we should be good. Okay. So let's go back to where I was, which was the synchronized chunks. Yes. Okay, cool. So then we get this. This is just going to pop it. No suitable constructor exists from void to stood future Minecraft chunk. Okay, so this pop function should give us. Yeah, should give us the next thing in the queue, is what I would assume. Let's just look this up real quick. I imagine that's how the queue works. That's how it usually works. So, yep, we got these things: size, front, back, push back, pop front. This is the wrong queue though. I want C++. There we go. Let's check this out. And pop does not return anything. It just pops. Oh, okay. Well, thank you for letting me know. So I guess what we'll do is we'll say that equals front, and then we'll just say queued chunks for deletion dot pop. It's kind of annoying. I mean, I don't know. Most queue implementations actually give you that too, but that's fine. Okay, and what's this saying? It doesn't like. Okay, so it's saying it's returning a reference. So we'll do that as a reference, and we should be good now. Okay, cool. Langors is a wizard. It's really nice to have you here to help me out. So, okay, so now that we got that chunk, and you also don't like it. Yeah, I mean, most queues, it's like when you pop something, it's giving it to you too. But I guess that's how they decide to do it. I'm just gonna call that chunk instead. And so we'll say chunk dot get. Actually, yeah, I guess we should call this queued chunk. So this should be ready now. So we should be, when we say chunk equals that, we should be getting the actual chunk. And I'm going to do this before I pop it, just so that we don't lose that memory. Okay. And then basically what we want to do is we just want to remove this from the main array, and we also want to free it on the GPU. So this delete function should free it from the CPU, and then we'll free it from the GPU here. And then we'll just say, and that should set it to unloaded actually. So we should be good at this point. Yeah. Okay, cool. So that should be all we have to do. And then we just want to do the same thing here. And I'm also going to log it here, just so that we have this all written down. We can sort of see. And Asher, thank you for following. It's good to see you here. Okay, cool. So we've got this log, and we just want to make sure that we're doing this right here. Unloading from GPU, so we should be good there. Cool. And I like the eye pyramid lingors. Okay, let's go ahead and we'll do the same thing. We'll say if queued chunks for creation dot front dot is ready. And that is such weird like naming convention too. They have a capital I for is ready. That's pretty strange. Okay. Anyways, then we'll get a stood future chunk ref queued chunk equals queued chunks for creation dot front, and then we'll say chunk equals queued chunk dot get, and we just basically want to say chunk dot upload to GPU. I believe that should mark it as loaded, right? So once we upload it, yep, we set loaded to true once we get that done. Cool. So that should do everything we want, and then we want to pop this guy off of here. And we should also have these in loops because we want to keep doing this until we're done. And I'm also going to copy this just so that we have this written down as well. So we'll do that and that. And then I should be able to just remove that loop because we've sort of simplified things. And the reason I'm doing this too is because I think this is just so much easier to understand what's happening. We're queuing some stuff up, and then we're just kind of removing them from the queue as needed. So let's say, I guess while queued chunks for deletion.front is ready. So we'll do that, and dot size is greater than 0. And that, then we'll basically pop these. And I guess we could remove this because we no longer have to worry about it being ready because it's going to be ready automatically. Cool. So we'll just put this into a while loop, and that should loop through everything. And I'll do the same thing here. Well, that and that is greater than 0. Okay. We should be good there now. Cool. And Langors, I don't think you can use is ready. It's not part of the specification, I believe. I think it's specific to MSVC. Okay, so that's why they have the weird naming convention. Yeah, I'm going to look at check if stood future is ready. C++. So I'll see what they say to do on this. Apart from calling wait until with a time in the past, which is equivalent, there's no better way. You could always write a little wrapper if you want a little more convenient syntax. So f wait for 0 seconds. Stood future status ready. Okay, is it possible to check if a stood future is finished or not? As far as I can tell, the only way to do it would be to call wait for with 0 duration and check if the status is ready or not. But is there a better way? The function is deferred. This will never return true, so it's probably better to check wait for directly in the case where you might want to run the deferred task synchronously after a certain time has passed. Okay, cool. So looks like we can just sort of do this thing. I'm going to copy his implementation because that might be nice. So we'll put this up at the top of here. Right there. So this should just take in a future and tell us if it's ready. Cool. So I'll use that instead. Thanks for letting me know, Langors. And Icy Woods, did you create the physics code for the 3D engine, which you made a YouTube video showcasing, or was that box 2D converted to 3D? I did create that physics engine, but I was following along with a book, which was written by Gabor Cesar, I think is how you pronounce his name. And it was the best book I found on the subject, and the only one that really made me understand how physics works. So, or that helped me, I guess. I think it's called Physics Cookbook. Yeah, it's this thingy. So if you want a good physics book, I also have this linked in my YouTube descriptions and stuff, but this is the best thing that I could find on the topic. I tried the other physics book that everyone recommends, which is, I can't even remember the name of it, but I didn't like it. So yeah. And another terrible API. Yes, Langors, I agree. And you bought that book. Okay, cool. Yeah. So I think this was probably the best book. It definitely helped me create that engine, and it worked, which was super nice. So yeah. And tree, but if I use MSVC, what's the problem then? If I want to make it multi-platform, which I might look into just because it's nice to make things multi-platform, MSVC won't work with like Linux and Mac, I don't believe. So yeah. And yes, it is easy and simple. So the physics engine I had in my videos was basically just that thing, like that, his book. So it's not like I really added too much to it. It was sort of like a combination of his and the other book I read, which I can't remember. So yeah. But basically we've got all this stuff. What was I looking for now? So we got this update method. We loop through the chunk capacity. We basically just check if it's loaded. If it's loaded, we render it. And then if it's out of bounds, we queue it for deletion. Then we say synchronize the chunks. We should probably check the chunk radius first because this will queue things for creation. So that's good. And this is just like a little thing to make it go in a spiral. So yeah. So that should queue things for creation. Then we synchronize the chunks, which should sort of fix all that stuff up. And let me check the chat real quick. And you have the title of the other book written down somewhere. Yes. So that's also linked in my descriptions and stuff as well. I never really liked it as much. So yeah, I don't recommend it as much. It just didn't help me out that. It was good with concepts. Just I couldn't get any code working from it. So I didn't really like it. But yeah, what we're going to do though is we're going to get rid of this chunk worker, which it didn't even take me to the right function. It's this one. Yeah. We're basically going to remake this to be those functions I declared at the top. So let's go ahead and copy those 4 declarations. So we'll copy that, scroll back down, and we are going to implement these using sort of what I have in there. So this is the create chunk and delete chunk, and we can just sort of offload all this stuff. So this will generate the render data. Yep. So we can just sort of grab all of that, put it right there, and we'll say chunk equals, I guess we'll just do that, and then we'll say chunk coordinates equals xz. So this is just going to say all that stuff, and then it's going to say if the chunk exists, world save path, chunk coordinates, all that stuff, then we deserialize it. Otherwise, we generate it, and then we generate the render data. Okay, cool. Yeah. So this should be all we need. And that should set it to loaded when it's done. So this is just so much easier to understand. Oh, and then we can just say return chunk once we're done. And that should be everything we need. And then right here, when we're unloading, we should just have to do this. So this is way easier than what we were doing. And then we can just say return chunk. And it's a lot easier to understand all this than what I had before. So I do like this a lot better if it works. We'll have to see. So yeah. And I also tricked you into buying the Game Engine book. It's a great resource. Yes, Game Engine book was amazing. By Jason Turner, I think is his name. Those guys are just amazing writers, and it has so much useful information in it. Yeah. And being pointed to good resources saves a ton of time for people who are new to programming. Very helpful. Thanks. Yeah, no problem. If you want another good website too, Harold Serrano has a really good website, which I like to check in on time to time. So I spelled his name wrong. It's just Harold. But if you just look up haroldserrano.com, he's got his thing. It's a game engine developer. And if you go here, he has a list of books too. So I guess I should show his game engine because his game engine is actually pretty good. And I think he has some videos of it and stuff, which you can check out somewhere on his website. But yeah, he's got a list of books. And there's a ton of different books, and he has them all categorized and stuff, which is really nice too. So he's like got the architecture, 3D modeling, physics. So these are all the physics engines books that he used. Rendering engine. So yeah, very good resource if you guys ever want to check that out too. But yeah, this should be good though. I think we are almost there. Function definition for create chunk not found. It should be found because I just made it right there. But yeah. And then let's go up and just make sure I didn't miss anything. So we got the synchronized chunks, which should basically just add all this stuff up. And then this cleanup, I guess we should still have a cleanup function, which will just go through the queue and wait for everything to be done. So I guess we could just like copy that, and we could change it up a little bit to abstract this, that we're not doing this. And then we'll just sort of say while chunk.size is greater than 0. I'm actually going to grab that. So we'll do that, and we'll say if that, then we sort of do everything. Actually, we could just say stood future chunk, and then I could just say queue chunk dot get, which I think does just wait, right? So this should just wait for us until it's done. So that should be good. And then I'll just remove this. Oh, and I also have to change those functions too. I never used the function I created up there. Okay, so let's change this up to use our is ready. And then we'll pass in that. Okay, cool. So that should check if it's ready. And then I'm going to change this as well. And we should be good. So we can get rid of that too. Okay, cool. So we're all good there. And we are all good here as well. Okay, so this is basically just going to wait for the chunks, and then we free it on the GPU. And we don't care about any queue chunks because when we're cleaning up, we're shutting down. So I'm going to get rid of that. Oh, actually, I guess this doesn't matter. We should just loop through them and free it on the CPU and the GPU. Okay, never mind. This might be a good idea though. I don't know. Yeah, this is probably a good idea. That way we just join all the futures so that they're all done. So I think I will leave it like this. Okay. And then this should just do it again for all the stuff that's not done, and then it just frees the memory. Okay, cool. So I think that should be good. Let's just hit play and see what happens. I have no idea if this is going to work or not. There's a good chance I probably missed quite a few details when I glazed over everything, so we'll see. After I get this done, I'm going to start changing up the architecture a little bit so that we can start moving towards the physics. I want to change the way that I work, like have entities described and stuff, just so that we have a pretty straightforward to work on that stuff. But yeah. So this says chunk worker declared but not defined. That's fine. I don't want to have that, so we'll get rid of that now. And I think I just never took this out. Yeah. So we can get rid of that now. And we should be good. Cool. So it's running. Okay. So it looked like I was really excited. I thought it was working there for a second. Okay. And then we get an exception. So it looks like we're not doing everything correct. It was very close though. We almost had it. So we've got all this uploading to GPU, and we have loading on CPU, so that's good. Just looks like it never quite worked right because we didn't get the results. It wasn't showing anything. So loading on CPU, let's see what the first one is. 3.3, so then we should get loading on GPU 3.3, which should be all the way down here. Yeah, loading on GPU 3.2. Okay, that's fine. So it's going to be in a different order just depending on whatever is ready, which is totally cool. Or actually, maybe it's going in reverse order, which isn't cool because I do want it to go. I don't know. This is just all sorts of different ways. Okay, yeah, but it looks like we are loading them to the GPU too. So that looks good. It's just in a really weird order. Okay, so yeah, I think that's all fine. Let me run this again and see what happens just to see if I'm missing something else. Fixed donation limit, if it is easy. Donation limit, there shouldn't be a limit as far as I'm aware. So I did check that, SE Woods, by the way. And I think you should be able to just type it in. So like, I think if I just go to, and it's going to show me myself. This is weird. Okay, let's get off of this. Nope, I got to go to here. Nope, this isn't what I want. Okay, so I can't even figure out how to get to my own stuff, guys. This is bad. Twitch has so many different things, and it always confuses me because I forget how to get to the different things. Okay, let me go to something else because I know where the link is over here. No worries. Yeah, I don't think it should have a limit, though. I did check it and stuff, and if you're going through the About Me section on my Twitch page, I think you should be able to just type in any limit, so that should be good. But I might double check it again too afterwards just to make sure that that's right. And if you're in the Discord, maybe you can like send me a picture of what's happening and I can check that out and see if I'm missing something. But yeah. Okay, so we're doing some freeing extra time. So it looks like we're freeing stuff extra. Yeah, it says we tried to free invalid memory that was never allocated. So that's definitely happening. But what I'm wondering about is it doesn't look like it's rendering anything, which is kind of weird. That makes me believe that we're just never getting in here. So I'm just going to put a breakpoint here. Oh, and I think I know why now too. Yeah. So if we put the breakpoint in here and I actually get that working. Yeah, notice that breakpoint's not getting hit. Why is that breakpoint not getting hit? Because I forgot to do the one thing that's most important, which is when we synchronize the chunks, right here, once we create a chunk, we need to actually add it to our main array. So we've queued the chunk and everything, but we've never actually added it to our array. So we should just say for int I equals 0 until I is less than chunk capacity I plus plus if chunks I dot loaded. If it's not loaded, and then we'll just say chunks I equals chunk. Okay, cool. So we just copy it into our array, then we break. And if we don't find any, we should probably log a warning, but for now, I will be fine with that. Let's see if that fixes our problem. And how's it going, Flare YouTube? Okay, yep, we hit the breakpoint, so that's good. So if I go back into here, cool, yeah, we're getting chunks now. That's good. So it's working. And it's still going fast. But we're not unloading stuff, so that's not good. Yeah. And whoa, Essie Woods, thank you so much. That is a lot of money. Thank you. I might have to reinvest that into the channel and stuff. And I don't know. I'm not lacking in any tools or stuff right now, but we'll see. Thank you. That's awesome. So we're getting in a pretty good place, almost. It looks like we have problems when we're freeing stuff. So I need to fix that real quickly. Yeah. And you figured it out. I can see that. Yeah. Thank you again. That's awesome, man. So if we go to the synchronize chunks function real quickly, I'm just going to go ahead and fix this up so that we fix the same problem we had over here. So basically what we need to do is we need to loop through the chunks here and mark it as not loaded. So if chunks I equals chunk, which it says we don't have an equals operator for chunks, so we can just do, I guess, .x equals dot position dot chunk position coordinates. Okay, chunk coordinates equals this chunk's coordinates. So these are the same chunks essentially. Then we'll just sort of say chunks I equals chunk. Okay, cool. Yeah, and that should be fine. Okay, so I think that should fix our problems now too. Yeah. And we should be back to where we were before, except we now have futures doing all the work. But now I'm noticing some lags too. Whereas when we were doing it with multi-threads and ignore this, I still have to fix that. When we were doing this with the multi-threading, there was no lagging. So that kind of concerns me. What I'm guessing is happening is it's just like our wait function. Yeah, and this still isn't working properly when we exit. So I'm going to have to look into that. But what I'm guessing is happening is this is ready function is basically just messing with us. So if we do this, just change that to -10 to see if maybe that changes anything. Okay, so we've got this. Yeah, we're still getting a little bit of lag spike every time we load new chunks in, which is not really cool. Compared to before where it was like there was no lag spikes. Yeah, you can totally see it in the CPU stuff over here too. So if you look over here, you can see every time we hit a spike. That's that. Let's profile. Let's see what's going on. So actually, let's go into release mode too real quickly and see what happens there. So, and for YouTube, progress is going pretty good. So we just switched over to a different multi-threaded paradigm using futures and stuff, which just makes it easier to manage the code. And then I want to start working on the physics and see how that works out. So yeah, going good though. Okay, so once we go into release mode, yeah, we're still getting little bit of lag spikes there, which really isn't cool. I don't want that for sure. So let's go ahead and just debug this real quickly. So we'll record the CPU profile. And then I'll go ahead and move a little bit, and then we'll take a look at one of those spikes. Okay, cool. So we got that. I'll stop recording, and we'll open the details. And I'll select like that range. Well, I'll just select the whole thing. So we'll open the details. Okay, invoke a break all or hit breakpoint. Okay, so I'll just hit a break all, which I need to do somewhere over here. Where is it? Okay, there we go. So we'll do that, and then we'll analyze this stuff right here. So let's take a look at what's happening here. And tree, maybe adding SPF counter might help. What do you mean by SPF counter? Like frames counter? FPS, yeah. Okay, I think that's what you meant. With some quick debugging. Yeah, we do have a FPS counter on like the window title and stuff, but I do want to drill into this a little bit more because I'm not sure what specific part is causing this. And Essie Woods, what frame rate do you have when displaying a black screen? I have no idea. I have it locked. So, so Tree, you're saying seconds per frame. Yeah, so we do have that showing too. And I have my frame rate locked because I am using VSync, so it should be like 60 frames per second is the normal amount. But yeah. We'll take a look at this real quickly too, though. And it looks like it's just showing me this thing for whatever reason, but I want to look. Okay, here we go. So here's the hot code. So it looks like create chunk, and then this stuff is taking the longest time, which makes sense. I wonder if it's because I called the wrong protocol. So I said, if we go back to here, to start these with async as the launcher. Yeah, which makes me think it would launch asynchronously. So I think that's fine and stuff too. But yeah, languages, you can measure both FPS and SPF, and both can be useful. They're both correlated though. Yeah. So I have seconds per frame showing up here. So we've got that just like kind of constantly running. And you can see the hitches and then like the frames per second jump a little bit too. But yeah, it would probably be nice if I actually logged that and stuff too. But yeah. What I'm interested in though is if I'm actually launching these asynchronously or if they're happening synchronously, or if something I'm doing is happening synchronously and that's why it's not working. Right. So stood future causes lag. Let's see what this does. Okay, async. Async will store its own vector copy twice. You should use stood cref and make sure the futures are retrieved before the vector dies. Okay, so this isn't anything to do with what I'm having. Yeah. This is strange. I think it might just be because of whatever paradigm they're using, or it's launching separate threads. I'm not completely sure though. So we may have to look into this a little bit more afterwards. It looks like the destructor calls the wait function automatically too. So I may not even have to do this as well. I'm just going to go ahead and do that, and we'll see if we can exit now without breaking things. Because like you'll notice too that in the beginning, I don't have control of my keys. I guess you guys can't notice that, but like I can't press key bindings and stuff, and it's not working properly. Okay, we're still having problems at the end, and it's trying to free invalid memory. So, oh, you know what? I think it's just because when I do this, well, actually, no, that shouldn't matter. Okay, so we'll look into that afterwards. That's a different issue altogether. But basically, this should be fine, I think. And oh, okay, I think it's probably this. It's because I didn't actually tell this one to launch asynchronously, which is exactly what Langors warned me of, and I just completely did not do that for that function. Okay, let's see if that fixes it. Hopefully it's just that simple, and it was like, no, I'm still getting a little bit frame ratey. Yeah, you can notice like if I move my camera, you can see it kind of jerk every time we load something in. So that is weird. Okay, anyways, I'm going to stop worrying about that for now. And for the physics, this is going to be pretty difficult. I don't think I'm going to have time to do that right now. So I think I'm going to probably leave off the stream here. So basically, we just sort of refactored this to work with futures, which may or may not have been a good idea. It definitely makes the code a lot easier to read, and I may have to just look into a couple articles to see if I'm doing something wrong by the way I have this set up. But yeah, so that's good. And then in the next episode, what I want to work on is just getting some basic physics up and running. So yeah, just like very basic stuff where we can jump onto a chunk and actually like start running around and stuff. So that should be pretty easy to set up because everything is just in a grid and we just have boxes. So yeah, looking forward to that. Thank you all for coming again. And SC Woods, thank you again for your donations. That was insane. So I really appreciate it. And it was good to see you guys. And I'll hopefully see you guys next time. All right. See ya.